What is up, team? I am the Master's Math Teacher. Now, over the last few videos, we learnt how to use set and interval notation. Now we get to apply that to graphing using something called a relation. So jump on board and let's get into it. So first, let's define what is a relation. So what a relation is, it's defined as a set of ordered pairs. So let me write that. It's a set of ordered pairs. So what do I mean by ordered pairs? You've actually dealt with ordered pairs quite a lot in the past, but they may not have been called it. So an ordered pair is just x, comma, y. So we've got our first value and our second. So that's called an ordered pair. So a relation is just a set of ordered pairs. So if I write that, I'm going to write an example of A equals the set, remember that set, of ordered pairs. So let's do 1, 2, 4, 9, 2, 2, and let's go -1, 3. So because this is a set, and we know that because of the squiggly brackets, of ordered pairs, so x, y, etc., etc. So this is a relation because it is a set of ordered pairs. Now we can actually graph this relation. So we've got 1, 2, so 1 across, 2 up, so about there. Now when we're plotting, we like to actually write the coordinate as well next to it. We've got 4, 9, so maybe here. Now mine isn't to scale, but you get the idea of what's going on. 2, 2, so we're going 2 across, 2 up. And we've got -1, 3. So over here. Okay, so this is a relation. Now we don't actually join the lines because it's not a graph. We're not connecting them, okay? So this is just saying it's the set of these 4 coordinates, not what's in between. So now we can explore the terms domain and range. So the term domain, what the domain is the set of all x coordinates. And now really important here, it's all the x coordinates, okay? We've really got to note that domain is the set of all x coordinates, not y. So if we were to write this, what we do is we write the domain of A, and we can actually write dom A, and I'll write in brackets dom up here. We can write dom of A equals the set, and then let's look, what are the x coordinates in A? We've got 1, 4, 2, and -1. Now when we write these, we write them in numerical order, so from lowest to highest. So we've just got -1, 1, 2, and 4. So it's the set of all the x values. And I'll highlight all this in yellow because it's really important that we get across the domain is x values. The reason this is so important is because the range is our next thing. And you might have guessed it, it's the set of all y coordinates. And again, because we're lazy, we just write it as ran. Okay, so if I want to find the ran of A, the range of A, I need to look at all the y coordinates. So we've got 2, 9, another 2, and 3. Now if you remember back, we don't write the same value more than once. Okay, so when we're writing this, we actually just write 2, 3, and 9. Okay, we do not need to write 2 twice because it's already been written. And again, I'm going to highlight it in green. It's super important that it's all the y coordinates. That's the difference between domain and range. So that's a basic relation. Let's look at something a little bit more complex. Now, if you recall back the graph y equals mx plus c. That's just your ordinary straight line graph. Okay, so this is our straight line graph. Now, this is actually a relation. Now, why is that the case? Well, let's have a look. If we do y equals 2x plus 3, for every single x value I plug in, I get out a y value. So if I do x equals 0, I get y equals 2 times 0 is 0, plus 3 is 3. So that is an ordered pair 0, 3. If we do x equals 1, y equals, and we got 2 times 1, 2, plus 3 is 5. So again, it's another ordered pair 1, 5. So this is, if we were to say the set of this equation, we know that it is a set of ordered pairs. So how do we write that in relation notation? What we do is we write the set. We say x, y, so we're saying the set of all ordered pairs x, y. We write our colon, and remember that means such that in maths. So we've got the set of ordered pairs such that each of these ordered pairs can be found using the formula y equals 2x plus 3. Now what we also do is we write the domain in this scenario. So it's very common in the questions that they list the specified domain as part of this relation notation. So for this one, we're not going to restrict the domain. We're just going to say x is an element of reals. Okay, if you remember, reals is just negative infinity to infinity. So everything, we're not restricting it. So let's graph this to get an understanding of what's going on. So we've got a straight line graph, y equals 2x plus 3. We know that the y-intercept is 3. We remember back to y equals mx plus c, knowing that c is the y-intercept. So I'll sketch it in blue. We've got the point 3 here. And we know it's got a gradient of 2. So it's going to look something like this. I'm going to put arrows at the end because that's quite important for this. Because we know that it's x is an element of all reals. So it's everything. So what we can say here, we can actually say the domain is all reals. Or if you wanted it in interval notation, negative infinity to infinity. Now we don't have to write this because it's already been specified in our relation notation. However, it's nice to write it at the bottom as well, just so that you have it for your own benefit. Now let's look at the range. So in this little blue graph, what is the lowest possible y value that I've drawn? Well, if we look, we know it keeps going down and down and down and down and down. It actually never stops. So in which case, the lowest value for our RAN is also negative infinity. What about our highest value? Sure enough, this graph also keeps going up and up and up and up. So the highest value is also infinity. So we can say that the range of this is also all reals. Okay, so this was a straightforward example because we're just figuring out what is the domain and what is the range. The domain is all the x values that it hits, and the range is all the y values that it hits. Now, it's not always going to be as nice as this. Sometimes we restrict the domain. So what we're going to do is we're going to do another example. We're going to use the exact same graph. So we're going to do a set of ordered pairs x and y such that y equals 2x plus 3. But this time, we're going to restrict the domain. So what I'm going to do is I'm going to say x is an element of negative 3 to 6. Now remembering what those brackets mean, we're going to negative 3, but we're not quite reaching it, so that's going to be a hollow dot. And we are reaching 6, so that's going to be a solid dot because of the square bracket there. So what we do is we draw our graph, We still know that it's going to hit 3. That's the y-intercept, 3. But now we have these restrictions. So what I'm going to do is at x equals 6, I'm going to put up an imaginary wall. Okay, because I can't go past that. That's what this is saying. An imaginary wall at x equals 6. We also have another imaginary wall at x equals -3. So again, I'm going to draw this wall. Now I'll grab out my blue again. And we're just drawing the same straight line. But once we hit this wall, I'm going to stop. Now I know I'm reaching +6, sorry. So I'm going to put a solid dot. And I'm going to just draw the little dots there. What that's saying is if it wasn't restricted, it would keep going like that. You don't have to do that if you don't like. I'm just doing it for visual sake. And again, we're going down to here. We're hitting -3. We've got a hollow dot here because we don't actually quite reach it. And again, this would be what happens if we didn't restrict it. Now, my graph is not quite to scale. You'll find out why in a second. But let's take a look at the range of this. How can I find out what the top y value is? Well, we know it occurs at x equals 6. So to find the y value at x equals 6, we can shove it into the equation. Y equals 2 times 6 plus 3. Y equals 12 plus 3, so 15. Okay, so this point is at 6, 15. Now let's look at the bottom point. Again, we shove it in. We've got x equals -3. So our y equals 2 times -3 plus 3. This is -6 plus 3 is -3. Okay, so our coordinate is -3, -3. Now you can see why my graph isn't to scale, because obviously that would be down here somewhere. Okay, but that's not relevant. The main point to grasp from this is where are the points, okay? And you can find that out even if your graph isn't quite accurate by plugging in the points. So then if I wanted to write the range, my range. So the smallest y value is -3. The biggest y value is at 15. Now I reach 15 because it's a solid dot, so I'm going to put a square bracket. But I don't reach the -3 because it's a hollow dot there. So my range for this relation, given that these new restrictions on x, is -3 to 15. Okay, let's do another example. This time, we're going to deal with a parabola because the same concept applies. So I'm going to say, my new one is the set of ordered pairs, x, y, such that this time y equals x squared plus 2. Now for my first example with this graph, I'm just going to say x is an element of all reals, just so that you get an understanding of what does this graph look like and how does it compare when I restrict the domain. So I grab out my Cartesian plane. It's an x squared plus 2 graph. Now if you recall when dealing with parabolas, this is a parabola, x squared, but it's moved up 2. Okay, so our turning point is up here. And it's a smiley face because there's no negative, so it looks something like this. And we got told that the domain is all reals, so we don't have to worry about any restrictions, no imaginary walls just yet. So, when finding the range, what is my highest y value? I'm going to do highest first this time, and you might see why in the next example. What is my highest y value? Well, it keeps going up and up and up and up and up. So it reaches infinity. Okay? So the highest value is infinity for y. What about my lowest y value? Is it negative infinity? Well, no, that would be all the way down here. That would go all the way down, but that's not correct. Okay, so it's definitely not that. It's actually just 2. That is the lowest possible y value that this blue graph hits. And it's actually a square bracket because we hit this point y equals 2. So my range for this parabola is 2 to infinity, because that's my y values. It goes from 2 all the way to infinity. So for the final one I want to do, I'm going to do the same graph, but I'm going to restrict it. X comma y, such that y equals x squared plus 2. But this time I'm going to restrict it, and I'm going to put the restrictions as x is an element of -2 with a circle bracket to 4 with a square bracket. Close my set notation. So pop up a Cartesian plane. Now, same graph. We know we start at our turning point, 2. Okay, it's going to be a smiley face parabola. But again, because we're restricting it, I'm going to put up my walls. So I've got 4 here, -2 here. I'm going to put up my imaginary walls. I'll grab out my blue pen again and start to draw the parabola. It's going to look something like this. Okay, we've got a solid dot here and a hollow dot here. Okay, and we've got that point is 2. So we might actually be able to see from the picture where the biggest and smallest y values are. I want you to pause the video and see if you can find out the range. So let's have a look. What is the highest y value? Now we can actually see that it's right up here, okay, at x equals 4. How do we find out what the highest y value is at x equals 4? Well, we plug it in. Y equals 4 squared plus 2. That's 16 plus 2. So y equals 18. So we've got the coordinate, or the ordered pair, at 4, 18. Is my lowest point over here? Well, no, it's not actually. The lowest point is still right here. And we can tell from the graph. That's why we need to draw the graph and be visual. Okay? So the lowest point is still at 0, 2. Even though we have a negative x value, that is not the lowest y value. So we need to visualize it as well. Okay? So if I want to write my range now, my range, it's still going from 2 because that's still my lowest y value. And it's going up to 18. And it's got a solid dot there, so it's also a square bracket. So there's a few tips that I want to give you when solving these questions. What you need to do is graph it accurately. Okay, that means finding this point here, so the first point, even though it wasn't part of our question, even though it actually wasn't relevant because it's not the highest value, I want you to find it so that you know what the graph looks like accurately. Because if I drew this inaccurately, okay, let's draw an example where this is inaccurate. So I'm drawing my Cartesian plane. I know my turning point is at 2. And I drew my wall, say, here for -2. And I drew my wall here for 4. And I went like this. Okay? This might look like my new maximum. This might look like it's higher. But we know that's not true. If we actually find out these 2 points, so this one we found out was 4, 18. And this one would be -2, let's plug it in, y equals -2 squared plus 2, 4 plus 2, 6. Okay, this is clearly lower than this one here. This has a y value of 6, whereas this one has a y value of 18. That's clearly lower. Okay, so make sure you draw these accurately. It's super important. Then find which 2 points is your highest and which is your lowest based on this accurate sketch. Then finally, the lowest point is going to be the bottom of your range and the highest point is going to be the top of your range. In doing this section, you might also find something called an implied domain. Now don't fear, I will be doing a video based on implied domains. However, this video is already too long, so I don't want to drag it out too much more by putting it in here. You can find that in one of the other videos. So that's it from me, folks. I hope you now have the skills to tackle some of these questions surrounding relations, domains, and ranges. I'd wish you good luck, but I know you don't need it. Go smash out some mathematics. And as always, if you liked the video, give it a like. If you didn't, give it a dislike. And let me know in the comments what I can do to make these videos better. If you have a topic you want me to cover, let me know in the comments below.